Here we're looking at modulus functions and some inequalities. So graph sketching is going to be essential, and in fact part A asks us to draw a sketch. Y equals modulus 2x minus 5. So I'd probably think about even just 2x minus 5. First of all, y equals 2x minus 5 is a straight line. Gradient 2, so a slightly steeper line than y equals x, and it's going to have a y-intercept of minus 5. So we're going to have a steep line going down like that, minus 5. And if you think about it, for y to be 0, x must be 5 over 2, or 2.5. Okay, that's without modulus signs. So when the modulus signs come in, everything that's under that x-axis gets reflected up. We get the characteristic V shape. So our answer to part A of this question is a graph. It's still going to have this part that comes down to 2.5. Then it's going to have the V shape going back up. And where the intercept was minus 5 before on the y-axis, it's now positive 5 on the y-axis. Okay, so this is y equals modulus 2x minus 5. It does say state the coordinates of any points where it cuts or meets the axes. So let's just write those professionally. We've got 2.5, 0, and we've got 0, 5. Good, part A done. Part B, find the set of values for which, well, the graph we've just drawn is greater than 7. So I'm going to draw a line across the graph at a height of 7. And we're asked, when is our modulus graph greater than 7? So when is it above this line? And we can see there's 2 points of intersection. We have to do a little bit of algebra to find those. So for part B, we're going to start with some algebra. I'm going to treat it as an equals inequality to start with. Let's look at 2x minus 5 equals 7 to find those points of intersection. Or remember, you get 2 cases. So one, you just ignore the modular signs. 2x minus 5 is 7, 2x is 12, gives us x equals 6. And the second situation when you're solving an equation with modular signs is, if it's not 2x minus 5, then it's the negative of 2x minus 5 that equals 7. And if you simplify that, minus 2x plus 5 equals 7, and you get x equals negative 1. I shouldn't really make my sketch from earlier more complicated, but I'm going to do it. It's a bad habit. We've now figured out that that's minus 1 and that's positive 6 where those graphs meet. So to come back to the question, the inequality that we were looking for, we want the modulus graph above that height of 7. So therefore we either want x to be less than negative 1 or we want x to be greater than positive 6. That's the range of values satisfying that inequality. Okay, part C. It's a new inequality. The modulus graph is the same, but we've got a different graph to compare against. So I think I really will draw a new picture now for part C. So let's recap. The modulus graph, down and up, 2.5 and 5. So this new graph, y equals x minus 5 over 2. Y equals x minus 5 over 2, so that's a straight line, gradient 1, with an intercept of minus 2.5. So actually, if you think about it, it's going to come like that, and these two graphs are just going to touch each other. You're going to have the same x-intercept at that point. So let's look at the inequality. What's that asking for? It's saying, when is the modulus graph above that new line that we've just drawn? Well, the answer intuitively is kind of pretty much everywhere, except at that one single point. At that point, they're in the same place, so we can't say that the modulus graph is above the new line. Okay, so everywhere except x equals 2.5. How do we write that in set notation? Probably the laziest way, the easiest way, is to say that x can be any real number, but x cannot equal 2.5 or 5 over 2 if you write it as a fraction. So all real numbers except 5 over 2.